Hello, this is Mr. Briggs. I'm coming to you today from somewhere in the Siberian wilderness. It's dark out, and all around me are the wolves. The wolves are everywhere. Let's get started with math. Okay, today's lesson is 2.1, Walking to Win. We're doing lesson 24 through 25, A through B. The ACE problems are 1, 29, and 34. And then this is sort of a double lesson. Its second lesson is pretty much just the sequel. It's the same thing. It's just makes you think about it a little bit harder. Is lesson 2.2. Go ahead and take 2 days to do this lesson. Well, take a day to do 2.1, a day to do 2.2. We're going to be doing crossing the line, lesson 2.2, and the lesson is on page 25 and 26, A through D. And our ACE problems are 2 through 5, 35 through 37, and 43. And our learning target is that I can compare two or more linear equations based on tables, graphs, or equations, and interpret the point of intersection. Okay, let's go ahead and get some notes in. Okay, just to review briefly, we have linear equations. And a linear equation is when we have something set where y equals m times x plus b. And b is our y-intercept, and m is our coefficient. Okay, the coefficient is what we're multiplying x by, and the y-intercept is where we're starting, where our line crosses the y-axis. Okay, and the only new thing that we really need to put into our notes is this right here, the point of intersection. And the point of intersection is where two lines cross, or the point where they share the same value. So for instance, if I have a graph that I have made, and I have a line where one line is coming up here, and I have another line right here, this would be the point of intersection, okay, right here, where those two lines intersect or meet, okay? And it lets you know that at this point they crossed each other. At this point they were equal. So imagine two people in a race, and that's the point in which one passes the other. Okay, let's get some notes in. The example I'm giving you is cab fare. The yellow cab charges $5 a mile with no minimum, and Union Cab charges a $2 fare at first, and then a $2 a mile fare after that. When is it the best deal to use each one? Well, let's go ahead and first make an equation. Well, if we say yellow cab, if x is my miles, my independent variable, and y here is the cost, well, I know that the cost is going to be equal to $5 times the amount of miles. So at 1 mile I'm going 5, at 2 miles I am going 10, at 3 miles I am going 15, at 4 miles I owe that cab driver 20. For some reason I wrote 25. Well, I just fixed that. And one important thing to mention is that at 0, when x equals 0, y is going to equal 0. Okay, because 0 times 0 is 0, right? And if you notice, I don't have a y-intercept. I'm not adding or subtracting anything to this. So I know when I graph my yellow cab, and I'm going to set these apart here where I've got 1 mile, 2 mile, 3 mile, 4 mile, 5 mile, and how about $5 and $10 and $15 and 20 and 25. Yellow cab is going to start at 0, 0, go to 5, go to 10, go to 15, go to 20, go to 25, and continue going up. But if I go 0 miles, I'm being charged 0 money. There's no y-intercept. Okay, none. So it's going to be equal to 0. Now Union Cab, on the other hand, is charging, okay, the cost here, or y, is going to equal $2 a mile plus I have to pay $2 right up front. So at 0 miles, I'm paying $2. So when I'm here at 0, and let me use a different color pen for this one, Union Cab is charging me a little bit of money right off the bat. And then at 1 mile, I do 1 times 2 is 2, plus 2 is 4. I'll use a thinner marker for this guy. Okay. And then at 2 miles, I'm doing 2 times 2 plus 2. It's costing me 6. And then at 3, it is going to cost me $3 a mile. And okay, 3 times 2 is 6, plus 2 is 8. And then at 4 miles, it's going to cost me $10. So if I take a look at this guy, at 0 miles, it's costing me $2 right off the bat, and that's kind of expensive. But then at 2 miles, I'm sorry, at 1 mile, it's only costing me $4. So I've already cheaper than the other cab. And then it's only going to cost me $6 after that. And then after that, it's going to cost me about $8 for 3 miles. And then at 4 miles, it's going to cost me an even 10. So if I connect those dots, as you can see, I have a point of intersection at a little less than a mile. So it is cheaper for me to use yellow cab if I'm just going down the street, maybe a block or two. But then, very quickly, it becomes cheaper to use Union Cab. Now, another way to think about this is that if you have these equations, what does it mean to have that coefficient? What does it mean to have that y-intercept? Well, let's pretend that these two equations represent the amount of money you're making or losing. What they mean is this. That plus 2 is my y-intercept. Okay? And my y-intercept represents what I start with. So, according to this equation, I started with $2. And my coefficient is what I'm multiplying by. And according to my coefficient, I'm making $3 every day, month, let's just say every hour. Okay? So I start with $2. Before I have even begun working, I got $2 in my pocket, and I have $3 happening every hour. I know that my values are going up. I know that I start at positive 2, according to this equation. But now, let's take a look at the second equation. Well, according to this one, I start at 15. So I'm going to start way up here at positive 15, right? Because my y-intercept tells me that. But my rate of growth, my coefficient, is negative 2. So I lose $2 every hour. So my money is going downhill rather quickly. And that's basically what these numbers mean. That the coefficient is my rate of growth. How far is my relationship increasing or decreasing? Decreasing would be negative, positive would be increasing. And my y-intercept, whatever I'm adding to this, is what I started at. All right, ladies and gentlemen. Your classwork for 2.1 is going to be the lesson is on page 24 through 25, A through B. The ACE problems are going to be 1, 29 through 34. And for 22, we're going to be doing pages 25 and 26, A through D. We're going to be doing ACE problems, 2 through 5, 35 through 37, and 43. All right, ladies and gentlemen, have fun.